the component.
The chromatogram, which is the graphical representation of the sample elution and response, is complete. Each peak is identified by the specific time that it leaves the column and passes through the detector. This is called the retention time. Each type of detector responds differently to compounds. Non-selective detectors will detect anything. The FID detector, for example, will detect anything organic. Selective detectors are designed to detect only specific compounds for analysis. The NPD detector, on the other hand, will detect nitrogen phosphorus only. Selectivity is the response of one group of compounds in a detector relative to the response of another group of compounds in the same detector. Sensitivity is technically what change in response is achieved per a change in sample concentration. The MDL speaks to how low of a concentration a detector can still provide a measurable response for when a measurable response is defined as a peak height 2 to 3 times the noise level. This is a graph that depicts the detection limit and the dynamic range for each of the more common GC detectors.
Here are the key points to remember. A chromatogram is the graphical representation of sample elution and response. Retention time is the time that an analyte leaves the column and passes through the detector. Detector response is characterized by selectivity and sensitivity. Selectivity determines the types of compounds that the detector will detect. Sensitivity defines the concentration levels the detector will detect. The minimum detectable limit, MDL, is the lowest concentration level the detector will detect. The dynamic range indicates the concentration range that the detector will detect. There are several types of detectors available for use. The purpose of the analysis and type of samples determine the type of detector used.
GC peak times really do tell the whole story of the composition of the sample being analyzed. A typical chromatogram is shown. Retention times are used to identify the components in a mixture by comparing sample peak times to known reference standard peak times. If the times match, it is very likely that the components are the same. The retention time is determined at the apex of the peak. Peak height or area is used to determine the amount of components present.